Hi, I'm Vinod. In the previous videos, we went over Verilog constructs and types of coding in Verilog. In this video, we will go a little deeper into digital design. As we've seen in the earlier videos, chips today are mostly SoC or system on chip. At the start of the digital design, the chip architect decides what logic can be achieved by having one or more CPUs or microcontrollers in the chip versus what logic needs to be implemented in digital design. The trade-off is that the implementation in CPU or microcontroller is programmable, whereas the implemented digital design is hard-coded, but it is faster than the former. The digital design that is to be implemented is typically split into multiple sub-blocks with multiple designers working on each of the sub-blocks. For the whole SoC, there will be an architecture specification written by an SoC architect that is available to the entire development team. The initial activity that the digital designer needs to do is to understand the architecture specification. From the architecture specification, the digital designer needs to understand and arrive at the inputs and outputs of the sub-block. As we've seen earlier, the input or output signals would all be interfaces. Some of these interfaces may follow standard protocols like the AMBA protocols or even I2C or SPI. Some others may follow proprietary protocols. If the interface follows a standard protocol, there may be design codes which has the logic to interact with the chosen protocol, which are readily available and ready to integrate. In this case, the designer would need to plan to integrate the available code. The designer would need to understand the clock frequency that the block would need to run on. This would depend on the following factors: the rate at which the signals to be processed are coming in, or the input rate, the rate at which the signals need to be processed, or the process rate, and the rate at which the outputs need to be sent, or the output rate. All these are captured in a microarchitecture document which would be written for each of the sub-blocks by the respective digital designer. The sub-block could be compute intensive, in which case it will have a lot of computation related logic. Alternatively, it could be control intensive, in which case it could be controlling other sub-blocks or components in the chip. In the subsequent videos, we will look at the development of code for a simple compute design and a simple control design. Happy learning.